Welcome to ESA. I'm Patrick Griffiths. I work as an Earth observation data engineer in the Earth observation program of the European Space Agency, ESA. Humanity is facing unprecedented challenges in the context of the climate and sustainability crisis, and Earth observation is a key technology to develop solutions to monitor impacts and the changes that are occurring. Today, we would like to introduce to you a new tool that we have developed, which is called the Green Transition Information Factory, or GTIF for short. The objective of GTIF is to provide decision support in the context of the green transition to enable various users to inform themselves and address their information needs in this context. Today, we're going to present to you 5 functional highlights that are enabled by the capabilities that we have implemented in GTIF. Let's start by taking a look at the capabilities that we have developed in the context of the sustainable cities domain. So one of the major problems in the context of the climate crisis is the heat development that we have in urban areas. And we implemented a few capabilities here that allow users to better understand what the relation is between heat development and sealed surfaces and vegetated surfaces. The first thing that we did here is to look at the maximum land surface temperature that is observable from space. And we did this for all of Austria. We're going to zoom in to the city of Vienna. What we see here is the maximum land surface temperature that was observed in the year 2021. And the color coding, as is shown here, it goes from yellow over orange to red, indicating increasing observed temperature with a maximum of 45 degrees centigrade observed here from space. Users can now use different background layers to better understand which urban structure types are associated with excessive heat development. We can, for example, here overlay the digital orthophotos to really understand in depth which areas are those that develop excessive heat energy. Another key tool that we have implemented is the Green Roof Impact Score indicator. So the Green Roof Impact Score provides a measure for the value of establishing or retrofitting a regular roof with a vegetated roof or a so-called green roof. You can imagine that in green residential areas where there's a lot of vegetation, which cools also the air temperature and the land surface, there's less excessive heat development, whereas industrial or commercial and densely sealed areas, heat development is much more excessive. The Green Roof Impact Score provides a measure for understanding the benefits of establishing or retrofitting green roofs on conventional rooftops. If we zoom out here a little bit, we see that in residential areas, the Green Roof Impact Score is rather low. Here, for example, we see green residential areas where the Green Roof Impact Score is very low. If we zoom out a little bit and go into the central areas or industrial areas of Vienna, we see that the Green Roof Impact Score is very high. And again, overlaying this with the high-resolution orthophotos, we see that these are urban areas characterized with a lot of soil sealing and relatively low vegetation coverage. So rooftops of buildings and cities can also be considered for producing renewable energy with photovoltaic panels. GTIF provides a couple of tools that support users to investigate related scenarios. So on the one hand, we have estimated for the whole country of Austria the suitability of individual rooftops for producing photovoltaic energy. This analysis takes into account rooftop geometry in terms of inclination, shading situation, the total electric power production potential under regular performance conditions. And again, the user can explore here a little bit which rooftops are especially suitable and for producing high amounts of photovoltaic energy. Another tool that we have developed in this context is the countrywide mapping of existing photovoltaic panels on rooftops. We can take a look here at the city of Innsbruck, where the detected rooftops where photovoltaic panels have been installed are indicated with this magenta color. In this case, actually showing a roof that has a vegetated rooftop and where photovoltaic panels are in place. So another tool that we have implemented in GTIF in the context of the energy transition is the site suitability analysis for photovoltaic energy outside of cities. What we see here in the map interface is a layer that characterizes the global horizontal irradiation, which is a quantitative metric for estimating the photovoltaic energy that can be produced in a given area. The color scale here ranges from blue over yellow to red and dark red, indicating increasingly high energy yields that can be achieved with photovoltaic panels. We have calculated the horizontal irradiation layer for different seasonal windows and also an annual average. Users can here constrain the solar irradiation layer in terms of its value range. And then the most important aspect for planning new photovoltaic farms outside of cities is the exposure and the inclination of the terrain. Additional constraining variables can be brought in a similar fashion as we have done it for the wind energy production, constraining here the total terrain slope to no higher than 30 degrees, and bringing in potentially additional constraining variables, such as the distance to the energy grid line or the distance to settlements. So wind energy production is an increasingly important topic in the context of the energy transition. In GTIF, we have a couple of tools implemented that support users to better understand this topic in detail. The first thing that we implemented here is a countrywide detection of existing wind turbines. So we mapped existing wind turbines in the whole country of Austria using openly accessible Sentinel-2 imagery and machine learning algorithms. What you see here is a map of the total distribution of the detected wind turbines. We can now zoom in a little closer here and see the individual detection bounding boxes. As soon as we click on one of these, we see the corresponding Sentinel-2 imagery is loaded into the map interface. We also see here the detection timestamp, as well as the confidence score for the detection through the machine learning model. Being able to map wind energy infrastructure, such as wind turbines, at the national level and in a repeated way is really valuable for decision makers to better understand the potential impact of new wind turbines or established wind turbines on wildlife and migratory bird species. Knowing where wind turbines exist is one thing, but many countries want to increase their renewable energy production and especially establish new wind turbines. And here GTIF provides some tools that support planning new wind turbine locations. What you see here is a layer that's called wind power density. It's basically a quantitative measure for the energy yields that can be achieved in a given area with wind turbines. We have calculated that for different turbine heights at 100, 200 and 50 meters height. And generally, the higher the turbine, the more energy you can produce there. What the user also sees here is the general situation that higher elevated mountain areas are more suitable for higher production of energy yields, whereas low-lying valley areas are related to lower energy production potential. If a user now wants to go into proper site suitability assessment to identify new areas for establishing wind turbines, they can do this using the GTIF tools. The first thing they can do is here to constrain the wind power density to exclude very low value ranges, so those areas that are only marginally suited to producing wind energy. The next thing they can do is to constrain the area for terrain situation. So for example, filtering out elevations that are higher than 2,500 meters or slopes that are steeper than 25 degrees. An important aspect is also to rule out all of the protected areas from this analysis, because we don't want to consider planning wind turbines in protected areas or national parks. The Add Constraints button down here allows users to bring in additional constraining variables, such as the distance to built-up areas, which is a pretty impactful constraining variable in a densely populated place like Austria. Once all of these constraining variables have been put into place, the user can investigate which are the remaining suitable areas and what are they used for currently. To do this, the users can again activate various background layers here that we have made available in an intuitive way in the GTIF tool. On the one hand, we can look at land cover products that indicate what these areas are currently used for. So in this map, we see that the areas that we identified as suitable are mostly within forest or pasture areas. Users can also look at the suitability of given areas for agricultural in terms of the agricultural soils that are in the area, and also the suitability of the soils for grassland. So the next set of tools and capabilities that we'd like to present to you are those that monitor the hydro energy production in Austria. As you can imagine, in a country with many mountains and valleys, hydro energy is an important part of the renewable energy mix. And also during times of overproduction in solar energy or wind energy, hydroelectric reservoirs provide a nice way of temporarily storing this excess energy. With Earth observation, we can provide proxies that allow us to monitor the lake levels in these hydroelectric reservoirs. And we did this in two different ways. On the one hand, we used Sentinel-1 and Sentinel-2 imagery to estimate the current lake level in these hydroelectric reservoirs. And this is what the users can explore here. On the one hand, in the analysis panel here, we have the full time series of surface water extent indicators that were derived. And users can then interactively explore these different situations. For example, here, loading in, loading a Sentinel-2 image during low lake level conditions, and then activating a split view and loading a corresponding a comparison layer that captures high lake level conditions. Here, using the Sentinel-1 radar image. So this provides us with a nice way of capturing the current, deriving a proxy for the current storage potential of energy in these hydroelectric reservoirs. But there are other instruments on satellites that provide an even more precise estimation of these lake levels, and those are the altimetry instruments that are, for example, on board of Sentinel-3. The problem is that these are not carpet mapping instruments, but rather provide one very precise measurement directly underneath the satellite. That's why they are not available for all of the hydro reservoirs in Austria. At ESA, we're continuing to evolve the green transition information factories in the future. We're adding more regions and more countries, and we're developing new innovative capabilities that address different aspects of the green transition. Moreover, some of the capabilities are being transformed into cloud-based replicable services that can be run for different areas and time periods. We want to eventually enable European-level insights to really inform and power the green transition ambitions and the European Green Deal. We thank you for watching, and we invite you to explore the Green Transition Information Factory at the URL that you see below.